Hello, everyone, and welcome to another episode of Code and the Coding Coders Who Code It. I'm your host, Drew Bragg, and I'm joined today by the man, the myth, the legend, tenderlove himself, Mr. Aaron Patterson. Aaron, for anyone who somehow doesn't know who you are, would you please do a brief introduction for the listeners?
My name is Aaron Patterson. I do go by tenderlove on the internet. I am on the Ruby core team and the Rails core team. I've been programming Ruby, let's say professionally since, when I say professionally, I mean getting paid to do it. That doesn't doesn't mean I'm professional at it. I don't know. I've been doing Ruby as a job since 2008 or so. So I've been doing it for quite a while. Yeah, I don't know. I have a lot of open source code and I write a lot of code and stuff.
Write a lot of code, YouTube video, blog posts occasionally. You do a little bit of everything.
Yes.
In all the ways that most listeners interact with Ruby you've touched, whether it be Rails or Ruby itself. So the way that this will work for anyone new to the show is I'm going to ask Aaron 3 questions. I'm going to ask him what he's working on, what kind of blockers he has. He can talk about a recent blocker he had if he doesn't have a current one. And then the last question will be for him to share something cool, new, or interesting that he has recently discovered, built. This is a little bit of a loaded question for someone like Aaron, but it'll be a great one once we get there. So you are a busy man working on a lot of cool stuff. So when someone asks you, what are you working on? How would you answer that?
I am working on many things. I don't know how it also depends on who it is. If someone I don't know is asking me what I'm working on, I'll just be like, computer stuff. I don't know.
That's fair. Not printer computer stuff, but computer stuff.
Yes.
Okay. Well, for your day job, what are you working on?
Sure. Yes. I think I have an answer for your audience, of course.
Okay.
But so at work, I'm working on 2 main projects at work. One of them is ZJIT, which is a new JIT compiler for C Ruby. And then one of them is better Ractor support in Ruby. And those are the 2 main things that I'm really focusing on at work at the moment.
Before we dive into both of those, because I am interested in both of those, I'm curious, like on your team at work, at Shopify, how do you get that kind of work, right? Because I think a lot of us work on application development. So we're building a Rails app. So it'll be, okay, hey, this is the slice of the application that we want to build next, or this is the feedback that we've gotten. On a team like yours, where you're almost building an ecosystem in a way, how does that work come down to you?
All of our work is driven by the needs of the business. The thing that we're trying to aim for is better utilization of our production machines. So whatever we can do to better utilize our production machines, that's what we're aiming for. And our team happens to focus on the language level of that particular problem. That's kind of how we get there. Yeah, of course, like ZJIT is for making sure we use a single CPU faster, not faster, but more, like more CPU. And then the Ractor concurrency or parallelism work is like, how do we use all of the CPUs? So that's kind of how they go together.
That's actually a really cool description of the 2 different projects and how almost different in a way they are. They're serving 2 different goals. How do you balance that? Sometimes I think, at least in my work, sometimes jumping between very back-end heavy work and very front-end heavy work, especially with it being generally 2 different languages, 2 different ways of thinking about building the thing. Sometimes it can be really hard to jump between those 2 different things. How do you deal with that in projects where it's like single CPU, concurrent CPU usage?
It is pretty difficult. At work, we have 2 different teams. We have a team that's specifically working on Ractor stuff. They're focused on that. We have another team that's working on the JIT compiler stuff, and they're focused on that. And I kind of move between both teams. I'm trying to help with any type of blockers that they have, or like just doing development. Wherever we're short, I'm trying to fill in on those particular things. And doing the context switching, it's hard. I don't have like a good answer for you.
That's fine. I mean, maybe you had like hey, here's how I do it at my level. I've been doing this forever, so I've figured out a trick. Or hey, it just never gets easier. You just do the best you can.
I really just do the best I can. But I guess the nice thing is with these particular projects is that the knowledge that I use on one project is also applicable to the other projects, because both of these projects, they're sprawling throughout the internals of Ruby. Like they touch everything in Ruby internals. So like if you work on stuff in Ractors, you're going to be touching like the garbage collector, for example. And when you're working on the JIT compiler too, you also have to touch the garbage collector in that case as well. Same with the virtual machine. All these things kind of get tied together. So you can take the knowledge from one and apply it to the other. It's really just like the specialized sections where it's maybe kind of difficult.
So in Ruby, we already have YJIT.
Yeah.
A lot of people are using YJIT, and it's been pretty successful. That, if I'm remembering correctly, was originally written in C and then written in Rust?
Yeah, that's correct. Yes.
So I guess two questions. What is ZJIT if we already have YJIT? And then what is it written in?
We'll start with the second one first. ZJIT is also written in Rust because that's just an easier one to answer. So YJIT is an awesome project. It's based on Maxime. It's based on her PhD work. It's really, really amazing, really great. It's what we call a basic block versioning JIT compiler. And I think it's her new research. Like this is her thing. And what it is like, if you imagine most JIT compilers are what we call method-based, where they'll take a whole method and they'll compile the entire method and then you're done. Whereas lazy basic block versioning is even more lazy than that. For example, let's say we have an if statement in your code and only one side of the if statement is taken. The JIT compiler, YJIT, will only compile that side of the if statement. So whereas a method-based compiler will compile both sides of the if statement. And whether or not both sides are used, the method-based compiler will compile both, whereas YJIT will only compile the single side. And where that's very, very helpful is that warm-up speeds are very low because we're literally compiling less code. It's very, very lazy. The other nice thing is any types that we discover at runtime. So when it's compiling code, it'll take a look at the objects that came in and check their types, and then it'll generate machine code based on those types. It's able to propagate those types through the system and generate more machine code specialized based on those types and not do type checking over and over. So you can imagine like every time you call a method on an object, it's got to check what type that thing is in a normal program. Whereas YJIT, when it discovers that types, on the first one, it'll do the type check. The first method call, it'll do the type check. But the second one, it's like, oh, I already know what that type is. I'm not going to bother doing it a second time. ZJIT is just a method-based compiler. It is more traditional JIT compiler. The idea being that we're taking the things that we learned from developing YJIT and implementing it and bringing those into ZJIT and seeing if we can get an even bigger speed boost out of that. Sorry, there's a lot of stuff.
No, I mean, it's good. If especially if folks aren't familiar with JIT compilers at all, YJIT especially being a very new way of doing JIT compilation. And it was interesting that you brought up like the boot time. I could be remembering this incorrectly, but if I remember correctly, that was sort of like the problem with Truffle Ruby. Is like Truffle Ruby was faster, but it took significantly longer to boot because it did some of that work behind the scenes.
Yeah. Truffle Ruby takes a really, really long time to warm up. And like going back to how the business drives the things that we develop, we deploy all the time. Like we're deploying over and over again. And I think this is a pretty common thing in businesses these days. So like that warm up speed matters. We can't just let it sit there and warm up for hours or whatever. It's got to be like now. So warm up speed is very, very important to us.
So because of how the two compilers work differently, ZJIT will take longer to warm up than YJIT, but because it does the whole method block, what is
faster? Let me give you. Yeah, that's a great question. Let's try and break down the advantages of a method-based compiler. So the advantages of YJIT, of course, are that we compile less stuff. Where the advantages of an entire method-based compiler are, when you compile a method, we break the code down into what we call basic blocks. These basic blocks are essentially chunks of code that don't have any branches in them. So if you think about an if statement, an if statement is going to have, say, 4 basic blocks. We're going to have one at the top, all the code that's executed before the if statement. We have two blocks, one that represents one side of the if statement and the other that represents the other side. And then we have a 4th block down at the bottom where those 2 blocks join. So you can imagine kind of a diamond shape. An issue that comes in is register allocation. In our CPUs, we only have a certain number of registers that we can use. And anytime we have values, if we can keep them in registers, so the longer that we can keep them in registers, the faster our program will be, because reading a value from a register is much faster than reading it from memory. So an issue with a lazy basic block versioning thing type compiler is that when you compile one side of that branch, we can't know necessarily what values will land in a particular register. We have to get those registers to align all the way through that diamond shape. And the only way we can see where those registers land is if we compiled the entire method. So going through the machinations or whatever process we have to do of getting those values to line up, that means we end up spilling a lot more stuff to memory. Spilling is a term in JIT compilers or compilers, just meaning we take stuff from the CPU registers and we put it into memory. We spill it to memory. So what we want to do is reduce spills as much as possible. And a full method-based compiler is able to reduce spills much more than a LBBV compiler. So those are the advantages that we're looking for. We're hoping to get out of this method-based JIT is that we'll be able to reduce spills.
So is this a situation where you're taking what you've learned from building YJIT, building ZJIT, and then ZJIT will be the thing? Or is this we're building ZJIT with the learnings from YJIT, but we're going to use both? Or is that not how?
It could go either way. We do expect that ZJIT warm-up may be slower than YJIT, but we don't expect it to be significantly slower. We're hoping that it's going to be in the range that it's nobody cares. But if it's outside that range, if it's very slow, we could imagine ourselves having a multi-tier compiler where it's okay, we'll start off with YJIT and we get that fast warm-up or low warm-up time. And then as the program is running, since we have more time, it's okay, now we'll use ZJIT to compile the method and get even faster code. So we could end up in a world like that, but just for simplicity's sake, we're hoping not to. We want to have ZJIT's warm-up time be so fast that that's just the one, and we just use that one. But it really just depends on how the numbers shake out.
So I guess the next logical question is, after ZJIT, does it become AJIT? Or is there a new, one JIT? I'm joking. Where YJIT was essentially that pattern of yet another JIT compiler, right?
Yeah, yet another JIT compiler, okay. Yes. And then ZJIT is just we're making it new.
Yeah, it's after Y. Got it.
Yeah. Should have started out at A. I don't know.
It's interesting because you're working on Ruby, right? You're working on Ruby improvement, but you're not actually writing Ruby to do so, right? Sure. You're writing Rust.
Yes.
Have you seen Drew Bragg's famous red jacket he wears on stage at conferences? Did you know that jacket was dyed with the blood of Node.js developers? Okay, that's not true. But you know what is? Jutoscale is the only autoscaler that consistently prevents request timeouts and backed up job queues. It's a better autoscaler because it tracks better metrics, analyzes them more frequently, and is run by a small team of committed devs. Jutoscale works with Heroku, Render, Fly, and AWS. Visit jutoscale.com to bulletproof your production environment.
This is a pattern that I shouldn't have been as unexpected as it was for me when I heard people working on Ruby were working on C, right? Because they're working in C to work on Ruby. You're working in Rust to work on Ruby's JIT compiler. What was learning Rust like? I'm still
learning it. I hate Rust. I'm so sorry. Okay. It's I don't like it. It's not a good language.
I was going to kind of go into Ruby's not your only language. You've been doing this for a while, so I'm sure. Yes. So I didn't know if learning Rust wasn't that hard because you've worked in languages like Rust, or like you just love Ruby and friggin' Rust is nothing like it and this is annoying. Or
Rust is fine. It's just like, it's fine. It's an okay language. It's better than C. But the bar is like
so low. Yeah.
Yeah. It's a very, very low bar. If I were to pick a systems language to use for this project, I would actually pick Zig. I love Zig a lot. It's a very, very, very good language. Biggest problem with Zig is the language stability. Like, I could never in good conscience recommend Zig as a language for a long-term project. You know what I'm saying? So I think it's just because Rust is trying to save you from everything. But sometimes I'm like, look, I know what I'm doing. Please just like leave me alone. And like Zig gives me that. It's like just enough hand holding. But if I want to do my own thing, I can, and it's really fine. And I can understand how people would like that. They want to do systems programming and they don't want to have to deal with segvs or any of those particular problems. In this case, like in a JIT compiler is essentially generating machine code at runtime. And no amount of safety checks in Rust are going to ensure that that machine code that we generated at runtime is safe. It can't make that guarantee. We're still debugging segvs. Like, it didn't save us from that. So like, what do we get out of it?
That's my next question is why then? I feel like when I had Kevin Newton on, he talked a little bit about the reasoning. That was a while ago, so I'll just ask you to reiterate why go with Rust then instead of... I mean, you said you like it better than C, so I guess there's that
huge, big reason. A JIT compiler is like, it's a big beast. It's a lot of stuff, like a lot of code you got to put together. And as far as like code organization goes, like C is terrible. Rust is way, way better at that. You can organize your code nicely. It's much easier to understand, find things. It's easier to make abstractions than C, so you can make nice abstractions. You don't have to like know all the other stuff that's going on behind the scenes. So I think it's like, for what we're doing, it's a very appropriate choice for sure. It just doesn't mean that it's my favorite.
This is one project, ZJIT, and working in Rust. And then flip the coin and you go over to Ractor work.
Yeah.
And I guess we got to repeat some of the questions of like, if anybody's unfamiliar with Ractors, let's talk a little bit about what Ractors do in Ruby. And then do you get to write Ruby now, or are we back in C land, or is it something
back
else?
In C,
back in C land.
Yes.
You're working on Ruby. You are not touching Ruby. Got it.
No. So for folks that are listening to your program that don't know, Ruby has a GVL similar to Python, which means that anytime you try to run CPU intensive code, it means that Ruby can only use one CPU at a time. You know, if you need to run Fibonacci or whatever in parallel, it's not going to happen. You can't do it. There are some things we can do in parallel. Like, for example, you can do multiple IOs in parallel. So you can like read from a socket in parallel. That'll work. But any type of CPU bound work, you can't do that in parallel. And that's all due to the GVL. So Ruby already has fibers. It already has threads. But the threads and fibers only allow us to have IO level parallelism, where we want CPU level parallelism, and Ractors solves this issue. So Ractors have their own GVL, but you can have multiple of them running in parallel. So just imagine, like, I don't know, you get all the safety of a GVL, but you get parallelism too. So that's what we're working on. And Ractors are different from threads. It's kind of like, I think the name came from like actors. It's like an actor-based system. It's Ruby, actors, Ractors. So the main thing with them is they put a huge restriction on the data that you can share. If you want to pass a value between Ractors, it's going to copy the whole thing, unless the whole thing is read-only. If it's read-only, it'll just share a reference. But if it's not read-only, it's going to copy it before it passes it to the other thing. I mean, that's kind of an issue, but not really. If you know about the data that you're passing between the things, it's not too cumbersome to say like, oh, I need to make sure everything's frozen. Where the issues come in, though, is like, lambdas, for example. Lambdas, this is a subtle problem, but people will run into it for sure. And they'll just be like, I don't understand why this is a problem. Let me set the stage for you. You've done define method before, probably, and you give define method a block. And that block captures the surrounding environment, right? So if you have a local variable defined outside of that block, inside the block, you can access that local variable. And it's because the block captured the environment that was surrounding the block. I feel like every, 2 or 3 years, people discover a memory leak in their application, and it's due to this. It's because they made a giant object, and then they did a define method or something, and now that giant object's sticking around in their heap forever and ever. And it's because the Lambda captured the environment. So let's say your define method with a block, let's say it writes to that local variable. It can do that. That's a thing it can do. And that's a form of mutation. You're mutating the surrounding environment. So what that means is that methods that are defined method with a block, you can't call them inside of a Ractor because they could mutate that surrounding environment. And Ractors only allow immutable objects to be shared between them. So we have these weird, subtle problems where you're why can't I this is a defined method. Why can't I just use this thing? So we're trying to solve problems like that. The other types of problems we're trying to solve are just bottlenecks inside of Ruby itself. I'll describe to you my favorite one so far that John fixed. This is a great bug, and it's very easy for people to understand the issue. So if you take JSON input and you're parsing a hash, for example, and the hash has a key, a string key. Maybe it's just hello points to world. So you have hello as a key. Let's say you parse that JSON twice. So you have 2 hashes, both with the same contents, hello world. If you get the keys out of the hash, that string hello, so those 2 strings, hello, those are identical strings. And I don't just mean the contents of the string. If you check the object ID of them, it's precisely the same object, right? And I think most people probably know about this. Think about how that works under the hood. How do we do that? Because we're parsing 2 different JSON documents. There has to be some sort of data structure that, how do I say this, makes them unique. You know what I'm saying? Looks it up and says oh, okay, that's the hello string. I got to go get the same one and stick it into this hash. So we have a global hash table. It's global inside of the VM, a global hash table where we look up those strings, then insert them into the hash. So you can imagine if you have 2 different Ractors that are both trying to parse JSON at the same time, there's going to be contention on that global hash table. So we had a issue filed, I don't remember how long ago it was, but a while ago, where somebody was yeah, if I try to parse JSON in Ractors, it's slower. It's literally slower than if I do it without Ractors. I could do it in serial and it's faster than doing it with Ractors. And it's because of the contention on that global hash table. So John implemented a fix, which was a lock-free data structure, a lock-free hash table. So we could eliminate that contention. And now it's faster. It's much, much faster to parse JSON between Ractors. And we're finding different bottlenecks these global data structures within the virtual machine. So it's kind of 2-pronged approach. One is fixing language features, that defined method thing that I was talking about earlier. And the other one is bottlenecks within the system.
I feel in Ruby, Ruby's a very mature language now. So a lot of every version is less, holy crap, look at this new feature, and more subtle little things that, depending on the type of programming you're doing, might not be anything that you're going to use. But something we're moving a lot closer to frozen string literals and being the default. And we got the new data object, which is essentially just an immutable object. Is that work because of the work that you're doing in Ractors, where you're kind of trying to create a better, less mutable environment for Ractors to run in? Or is it just so happen, you said, we want less mutable stuff. And like, yeah, this stuff's here too. They have nothing to do with one another. And I'm just reading into it.
Yeah, it's not particularly related. No. So the Ractor thing is coming in, moving back to the business again, talking about where our stuff comes from. We have an application at work. The workload on it is random. When a request comes in, we don't know if it's going to be mostly IO bound or if it's going to be mostly CPU bound. It could be either. We don't know. And it's a huge problem. So like, imagine you have an application like that and you're using a forking web server. So typically what you'd do is you'd pre-fork maybe, 1.5 times or 1.25 times the number of CPUs you have, some number, some coefficient. And let's say you have this random workload and all the requests come in, but they all happen to be IO bound. So in that case, like let's say you had a machine with 10 processors, just to make the math easy, and you're doing 1.5, so you have 15 processes. You're servicing 15 IO bound requests in parallel. But the machine, if you look at CPU utilization on the machine, it's like nothing because they're all IO bound. You could be serving more. You're capped at 15. Now, on the other end of the spectrum, let's say you have all CPU bound requests coming in and you're trying to service 15 CPU bound requests on a machine that only has 10 CPUs. Now your latency is getting messed up because those 15 processes are contending, all trying to get CPU time. How do we solve this problem? What we'd like to do is we'd like to have a way to automatically scale the web server up and down so that we can say like, oh, we have more capacity on this machine. We're serving 15 IO bound requests. We can spin up another and take more, right? Or, hey, we're serving 10 CPU bound requests right now. I don't want it. Don't give me anything, please. So we would like to be able to spin that up and have the web server automatically scale to whatever the load is on that particular machine. And we think we can do it better with Ractors than with any other concurrency primitive. That's like the ultimate goal. That's the world we'd like to get to. Of course, we're not like...
When you are at breaks in production, you want to quickly understand and fix it, not sift through logs for the next hour. That's where Honeybadger comes in. Honeybadger notifies you of errors, outages, and performance issues as they occur and helps you respond instantly when your systems go down. When you need to dig deeper, Honeybadger's advanced query engine helps you reach into your logs and grab just the information you need. With error tracking, performance and uptime monitoring, log management, and support for over 10 languages, Honeybadger is the best tool to gain real insight into your application's health and performance. Best of all, it's free to get started, and setup takes less than 5 minutes. Be sure to check out honeybadger.io. That's www.honeybadger.io. And thank you to Honeybadger for their continued support of the show.
It's gonna take
Slowly
a while
but
to get
surely.
there. Yeah. So that's kind of the thing that we're aiming for and what we're trying to drive these particular features. So it's not to do necessarily with that read-only data structures, but those for sure help. So
Right. Okay. So they help, but they weren't born of this project. They just help this project along.
Yeah.
How often does it happen that you potentially have like a larger project and you get like shoot-offs like what I just described that's completely inaccurate? But I'm hoping it does actually happen in your work where you're like, hey, we got to do like X thing. And it's like, cool, well, we can shoot this off. Like this can become its own feature within Ruby. So let's go build that thing. And then these multiple other things get done. And then that makes this main project easier. Does that happen at language level like it does sometimes in application development? Or is it not?
I feel like it happens all the time. It's just a very small scale. Every single project seems like an offshoot is basically what it is. Because the project's very nebulous. It's like, oh, okay, we need to make Ractors better. It's like, okay.
That's so well defined. I love it.
Yeah, like, what does it mean exactly? So we end up finding these like weird bottlenecks. I mean, a huge one that we haven't talked about at all is garbage collection. So that's a thing. It's like, oh, okay, well, are we going to dedicate resources to working on GC for this particular thing? Because GC is going to be a bottleneck as well. Just to answer that question, we are not putting any people on GC at the moment. Koichi is working on a per Ractor garbage collector. So the issue, like, just to tell folks what the problem is, I was talking earlier about we're finding bottlenecks on global data structures. So if you have any global data structures, of course, those multiple threads are going to contend on those data structures. And one thing that is a global data structure is our garbage collector. All Ractors allocate out of the same garbage collector. So you can imagine we get to a point where it's like, oh, we're contending on allocating objects or freeing objects or whatever. So what we would like to have is the GC per Ractor. And Koichi's been working on that. We're hoping that's going to ship in Ruby 3.5. That'll help a lot. But yeah, we end up with weird offshoots like that. The define method problem we were talking about earlier, we've got a bug to deal with that, a way that we can support that. We're working on something like that. So it seems like if you just looked at the ticket from the outside, it would seem like really weird. Like, why? Why are you doing this? But it's all to support this particular thing. In that case, I don't know if your listeners are going to care. I'm going to say it anyway.
You say it anyway.
I'll say it anyway. So like what we want to do is when we share a Lambda, sharing Lambdas between Ractors is a huge pain. It's a huge pain. Like I feel it's a thing people would want to do. John and I have tried to make Rails Ractor safe. We've tried to do it. Just as a way to figure out what stuff we need to work on. Because a lot of stuff we have to do is discovery. We're trying to eat an elephant here, right? Like, where do you start? We have no idea. So we're just trying to do discovery. I think like the first hiccup we landed on was like, oh my goodness, we've got all these Lambdas that we can't share. For example, the router has Lambdas. Every time you're doing special stuff in the router, it's going to have Lambdas. We got all the access support callbacks or whatever. Those are all Lambdas too, and they're shared throughout the entire application. So those have to be passed around via Ractors. The plan so far is we can detect when a Lambda tries to access an outer environment. So we can detect when it's reading. Okay. We can also detect when it's writing. So we can detect when you do write. So what the plan is if you do a write to the environment, we're going to raise an exception and say you can't share that. But if you do a read, that's fine. So like if you want to capture an environment, you do a bunch of calculations or whatever, and you want to cache that essentially by passing a Lambda around, good on you, have fun. It should work fine. But we also need to detect cases where like maybe you write to the local variable after you declare the Lambda. This would manifest as a race condition, essentially, if you allowed that. But we can detect that case as well. So we're trying to work on like loosening the restrictions for these things where it's like, if it's read only, if you're just making a Lambda that's just reading data, we're good, no problems. Right now, it's very, very restrictive. It's basically like, no, you can't do it. So, and that's, of course, a non-starter. I mean, think about like a Sinatra app. A Sinatra app, it's all Lambdas, right? You'd never be able to write a Ractor-based web server for it. It just wouldn't work. Just can't do it. So, yeah, that's fun, though. I enjoy it.
It's fun. I have a slight headache just trying to keep it all in my head. But yeah, sure, fun. Let's go with that.
I think it's fun because it's very challenging. It challenges the creativity in my brain because it's like, okay, well, we have this code. How do we support it? To me, that feels like a very creative endeavor because it's like you're forced to think in different ways. How do you solve this problem? So that's why I particularly enjoy this type of work.
How do you balance the work that you do for your day job at your mom and pop shop, Shopify, as you love to say? Every time, I've heard you say that about 10,000 times, but every time you say, I work at a mom and pop shop,
That's
Shopify,
right.
I'm just like...
I forgot to say this in my intro. Yes, I work at a mom and pop startup called Shopify. Yes.
I don't know why. It just makes me laugh every time. The same way that I laugh when my teenager groans at my dad jokes. Like, it makes me feel good on the inside. How do you balance that work? you just talked about two pretty intense things. Like, at the end of the day, I feel like your brain's going to need a rest. Maybe not, because you're Aaron Patterson. Because you're also on the Rails core team. So you also do Rails work at your level. Is that work part of your job? Or is that completely separate and that is just your hobby, labor of love? Why not?
It's also part of my job. I'm on the security team and we have to do security crap. Most of my recent work on Rails has mostly been security stuff, which I hate, by the way. It's terrible. If anybody invites you to be on a security team, just say no. Like, absolutely do not do it. This is my pro tip for you. Don't do it. It's terrible. So that's like most of the work. And we do that. It's part of my job, I guess. I do that during my day job. So also, what I'm trying to do is at work, I described two teams, JIT team and Ractor team, but we actually have more teams.
I was going to say that, there's got to have a team for friggin' everything, really.
Yes, there's more teams than just the two.
Shocking.
I work at a mom and pop shop, but we do have more than two teams. That's true.
And a handful of developers.
Yes, a few. These two teams are on what we call the Ruby infrastructure team. And we also have a Rails infrastructure team, which I am not on the Rails infrastructure team. I'm on the Ruby one. But we have a lot of folks working on Rails stuff and on the Rails side of the house. And I feel like a lot of my time is, especially working with Rails, isn't necessarily me doing it directly, but working with the other folks on that team to try and like level them up, get them contributing and more working on the Rails team. So I see myself as trying to multiply my effort, more managerial, I suppose. I start thinking about this. I'm like, I almost said a curse word.
You can curse. I curse. There's so many episodes. I'm like, I checked the box, explicit content.
Okay.
Yeah,
So,
I can't not curse.
I feel like I'm turning into kind of like a manager or whatever, but it's really just like, I want to get more folks leveled up so that we have more contributors coming into the Rails team and working on Rails itself. I don't know if this is common for developers or just people in general. So I was writing Rails apps and I was like, how does Rails work? That's how I started like working in Rails and contributing to Rails. And then I was like, okay, this is interesting. Well, how does Ruby work? And then I started going into that and I'm like, okay. And then like keep going deeper and deeper. And that's, I don't know if it's a blessing or a curse, but I feel like if my case is common, if that path is common, then we need to get more people into Rails so that they can keep funneling down. And
right, sure. Fall further and further down the rabbit hole.
Yeah, exactly.
Okay.
Exactly.
I guess that would make you the right person to ask. At the last RailsConf, Ufuk had people stand up at the various levels of contributions to Rails.
Yeah.
When we got to like, hey, if you have a commit in Rails, like stand up. I don't know how surprised I was because there was also a lot of first time to RailsConf folks there. So, but there were people that I recognized still sitting, which was somewhat surprising.
Mm-hmm.
How do you recommend someone get into contributing to Rails rather than my first one was I had a problem at work. We solved it. I felt like it should be in Rails. Great. That's a pretty straightforward. But if someone's just sitting there going, I want to work on Rails, I just don't know how.
Yeah.
How would you suggest they kind of go about getting themselves into that world?
Basically, I suggest the same way I did, which was just start reading the source code. Many times I recommend people, go take a look at the docs. You can contribute to the documentation. But I have to admit, like, I don't do that. I don't document my code. Are you kidding?
Okay, but to be fair, it is super important. Good documentation is crazy important. And like, no one wants to do it. That's why it's important, right? If everyone is documenting, it wouldn't be a problem. It wouldn't be that important. But because no one wants to do it.
I don't know, man. This is what Cloud is for these days. I'm like, tell me what this function does. I'm too lazy, man. Just like, do it for me. Do it for me.
The amount that I've used AI sparingly because I feel like at least 40% of the time I ask AI a question, it's wrong. And I've only caught it because like I know what I'm asking. I'm just asking it to like give me a different point of view. And it like spits out some shit. And I'm like, no, you're wrong.
Yeah,
that's completely wrong. And I'm like, oh shit, if people start using AI without knowing, it's going to get crazy. I think documentation is still crazy important. And also, what else are we going to train the AI on?
Of course.
If we don't
that's true.
Put real human work into stuff, the AI is not going to get trained.
I was just this morning, maybe we'll talk about this a little bit later, but just this morning I was like using AI. I was like, okay, if I have a measurement in lux and I know an ISO and aperture, can I calculate a shutter speed? And it's like, oh, absolutely you can. And it spits out a bunch of formulas. I'm like, okay, that's very interesting. And then I start doing the math. I'm like, math literally doesn't like it.
Your math doesn't math.
Yes. I was like, okay, can you plug a few numbers in there and give me an output for it? So it does that. And it's like, oh, these numbers don't seem right. I'm like, yeah, great job. But I'm like,
congrats, AI. It's called learning.
It's as if I asked a sixth grader to do this. And then
dude, that is actually a great description. I have nephews who are like 4, 5, and 6, and the confidence they have when they are giving me the wrong answer to something is exactly how AI talks to me.
It's more endearing when it's a child, though. Like,
sure, they're cuter.
Yes. So back to contributing to Rails, what I like to do, or what I recommend to people who don't want to write documentation is, though, please write documentation. We need it. Please, please. Yes, of course. So important. Start reading the source code. So in your application, you're using Rails or whatever, pick a method that you didn't implement, something that's implemented in Rails, and go read it and see how it's implemented. And unfortunately, this is like a steep learning curve. But once you start doing that, you'll kind of get an idea of the architecture of the internals. And then once you can get an idea of the architecture, you can fitting into your brain. It's like, oh, okay, well, I see a way. Here's a way we could improve this architecture. And that really drives ways to refactor or improve the internals. I don't know. It's high effort, but just read a lot, I suppose.
I feel like that was a big turning point or a big level up for my career, is when I got really comfortable reading the Rails source code, not getting afraid to be like, I don't know what this is doing. I don't know what the various options are. Like opening up Rails code and looking at the method and looking at everything that happens under the hood. I got a lot more confident in my day job. Now I'm reading more code, but got a lot more confident with Rails, was able to make a couple of commits to it because of that. So agreed, not just from hey, I want to commit to Rails, but like just to level up your day job, like knowing how the stuff you're using works under the hood is a huge, huge thing.
Sure.
I'll agree with that one. So the next question on our guardrails question is blockers. And you sort of talked a little bit about things that are blocking, especially with the Ractor
number
stuff.
2. Okay. So.
Yeah. No, that's great. I'm listen, you tell me when you have to go. I am here for you.
All right.
But yeah, sorry, we're only on question 2. You did sort of answer a little bit with the Ractor stuff. Blockers for Aaron Patterson, what do they look like?
Blockers. I think this is funny. We're doing stand-up questions, but we're both like sitting down.
I'm standing.
Are you? Oh, okay. Well, I'm not. For your listeners out there, I am sitting down for the stand-up meeting.
Blockers. Yeah, I modeled it after stand-up just because I'm like, people are generally used to like, what are you working on? What blockers do you have? Cool. It's a stand-up.
Blockers. My job is to like solve blockers.
That's a fun job. What's a recent blocker that someone came to you, say from the Rails infrastructure team, and you were able to get them unblocked? What does that portion of your job look like, unblocking people?
One thing that I'm actively working on at the moment, I don't know if you saw Hartley's talk at RailsConf, but it's very good. I recommend it. Go look up his talk. I'm sure it'll be in the show notes.
Yeah, I'll put it in the
I'm committing to your show notes.
There you go. Yeah, I'll put it in the show notes. I unfortunately did not make it to a lot of talks at RailsConf just because I was doing program committee stuff and running around like a headless chicken. But they're all up on YouTube now, so I'm slowly but surely working through them. Step 1 was rewatching Aji's keynote and then watching Marco's.
So good.
So good. Yeah.
So Hartley gave a talk about different improvements to Action View. And he was like, oh, I have these ideas and we should do this and this and this. And I watched his talk and I was like, yes, we should absolutely do that. You're right. So I'm trying to work with him on how to get him on block on implementing these things. So John Hawthorne implemented a precompiler for ERB templates. And Hartley in his talk was like, we need to upstream this. And this should come with Rails by default. And I was like, yes, it should. Please make it so.
The wonderful thing about open source, if you want it, make it so.
Make it so. So I am blessed that he is on the Rails infrastructure team, so I can ping him on Slack. And I was like, I like your idea. What do we need to do? So he's starting to work on that. The first thing is for template caching. Like another thing he was talking about in his talk was template caching. So we have to detect calls to render in ERBs in order to like figure out what the cache keys are. And we're doing that with basically a pile of regexes, which, as we all know, is like the best way to solve every problem.
Sure.
Just slap another regex on there. You're good to go. Actually,
yeah, no one needs to read this shit later.
No. And you know what? I recently read a blog post about how you're supposed to add /o to all of your regexes because it just makes them faster.
Yeah, that's exactly what that blog post. I'll include that blog post in the show notes too. This is going to be very long show notes.
Just all your listeners out there, just put that O on the end.
It'll be great.
/o at the end. It'll be everything's faster. It's just all better. But yeah, so he was talking about how to detect these render calls in a more robust way than a pile of regexes. And that's by using an actual Ruby parser. So the first step was getting this Ruby parser integration in and on by default. And I merged his PR to do that. So in Rails 8.1, we'll be using Prism for detecting render calls for your template cache keys. I asked to keep the pile of regexes around. It's a configurable option. So if you happen to run into any problems, you can like downgrade if you need to. But hopefully there won't be any problems, and then we'll just delete the regex based one later. So those are the things we're working on.
Is the work that Marco's doing on Herb and ERB on your radar?
Yes.
I hear parallels right now.
Yeah. Marco's work is awesome. Love his work. Yes.
Is that one of those, as you're working with some of this Action View stuff, you're considering the things that he's doing and seeing maybe this can get plucked and brought in, or we can make Marco's life easier by doing X? Or how does coordination with the community work at a Rails core team level?
Sure. I have to admit, I didn't think about it until just now.
Oh, okay, cool. Well, there you go.
So I've seen his work and I'm a huge fan. Like any way we can get language servers and stuff, that type of stuff. So I guess for folks that aren't familiar with his work, he's doing a lot of work on the language server and editor integration. Specifically, if I remember correctly, the talk he gave at RailsConf was about Herb, H-E-R-B, which is a language server for ERB. So making ERB better. Well,
it's a tool chain, essentially. It's multiple things. Yeah. It's the LSP, the parser for ERB and HTML and things. If you're not familiar with what we're talking about right now, go listen to the episode that came out right before this one, which would actually be Marco talking about some of that work.
We'll have a link to it in the show notes.
We'll have a link to it in the show. Yes.
I hadn't thought about that. We should, because I'm a huge fan of his work, and I think that type of stuff should just ship with Rails out of the box. I'm not sure what that looks like. Booting an LSP server in addition to your Rails server is like heavy lift, I think. Mainly because I don't think we want to maintain that type of complexity because that's like a lot of stuff.
Yeah. He has a long list of like, this is what I'd like to get out of Herb. Here's some tools that we can build because now we have a good parser for HTML with ERB.
Yeah.
We have a linter, we have a formatter, we have all these things that build on top of one another. And then oh, hey, also kind of compiling ERB is a little slow. Because we're doing it this way, we can do it another way now. And potentially this should be part of Rails where we treat our ERB views a little bit more like code, because it's sort of what they are. But yeah, I mean, he's got a lot of interesting ideas. And there was a lot of parallels in what you had just said. So I didn't know if, obviously it's not on your radar, wasn't on your radar. Sounds like it is now. But from a being on the Rails core team perspective, like how does that kind of community, I don't know if it's engagement or coordination or what have you, like how does the Rails core team keep tabs on like what the community is doing and things like that?
So how do we keep tabs? The short answer is we don't.
Okay. It's on the people building things to kind of bring it to the core team's attention.
Yes. Longer answer is like the way that we work on the core team is very independent. There's basically zero coordination among the folks on the core team. So like I go to conferences and watch talks. That's how I know about these things, or things that the team brings to me. But we don't make any sort of coordinated, concerted effort to know about these things. So the best way, if you have a thing you think should be in Rails, best thing for you to do would be to file a pull request or something like that. Or, I don't know, speak to one of us directly, like email me, or actually don't email me.
Don't email you if you are expecting a response,
yes.
Or your wife might respond.
Yes,
right?
That's a fact. Yes, for sure.
So the last question is my favorite. So
yes.
What is something cool, new, or interesting that you've recently learned, discovered, built, or building? Anything. Doesn't have to be coding related, but this is code and the code encoders who code it. So what do you got?
I'm working on another hardware project.
It's not an analog terminal bell.
No, it's not an analog terminal bell. That'll be in the show notes too. I love promising things that'll be in your show notes. This is great. So during the pandemic, I'm going to give a little bit of history here. During the pandemic, I bought a camera because I was like, I'm going to be doing a lot of meetings at home. I would like to have a high quality camera with which to show my face across the internet. So I bought a camera, and then I was like, I should probably learn how to use this as a regular camera. So that's what I did. And it turned into a hobby, which is a very expensive hobby. If anybody is into this hobby, you will know it's quite expensive. And one thing I learned about is that as a programmer, the problem with any hobby is like I somehow turn it into programming.
Of course, yeah.
Because that's like my actual interest here, apparently. I shoot my photos all in RAW. To be more explicit, I do photography as a hobby. I shoot all my photos in RAW. And what that is, when you shoot a photo in RAW, you're getting the data directly from the camera's sensor. Whatever the sensor recorded, that's what you get. And that's great and fine. But the problem is sensors are different. Each sensor is different. I have an Olympus camera. Even if you buy two Olympus cameras, like the data, it's not going to be exactly the same. So they calibrate these things at the factories, and the calibration is all done in software. So if you shoot in RAW, that calibration stuff doesn't apply to the RAW file at all, because you're getting truly the data that just came from the sensor. So like when your camera records red or whatever, it's not truly that color. You have to have this calibration applied to it. The calibration gets applied to it if you also record the image as JPEG. So the JPEG version gets the calibration stuff applied to it, but it also gets other, like, whatever they want to do to the JPEG. So, of course, me being the nerd that I am, I'm like, okay, well, I need this calibration data. I want this calibration data because then I can apply that to the raw photos. Like when I take them out of the camera, I can apply that calibration data and get better colors. It's true, you absolutely do get better colors. So what you do is they have these color tester things. It's like a thing with a grid of colors on it, but the colors are known in advance. You take a photo of that, and then in software, you lay a thing over it, and you're like, please fit this to these particular colors. And since the colors are known in advance, you can come up with the right coefficients to apply. Now, I know it's a long, like, yak shave, but here we go. Like, so, like, when they do these calibrations at the factory, they have these color charts, but you have to shine a particular color of light on it.
Okay. That makes sense.
So like think about during the day, like in the evening, the sun is very orange and the light that shines from it is very orange versus during the day, it's quite white. Our eyes perceive white differently. Like we'll look at white. It's not actually white. You'll notice if you ever mucked with the white balance on your camera, it's like, oh, why does this look all weird in my camera? I see white. Why does it look blue on here? But they record it at what they call D50, which is 55,000 Kelvin, like temperature, color temperature. Yeah. So if you want to reproduce what they do at the factory, you need one of these color checkers, plus you need a 5,000 Kelvin light source. So I'm like, okay, well, how do I get 5,000 Kelvin light source? Maybe you can buy a light that produces 5,000 Kelvin light. But then it's like, are you sure that that's the color that's reaching, is that actually the color that's at the color checker? Like, are we sure? So I'm building a color temperature sensor.
Of course you are. Yeah.
Yes, that's my current project at the moment. I've already spent way too much on this project.
Time or money or both?
Both. I've already bought so far 3 color temperature sensors. So you can just buy a color temperature sensor. If you try to buy like a commercial one or whatever, like a built product, they're very expensive. So even though I've already sunk time and money into this, I'm still saving money.
Because your time is useless.
Exactly. Yes. I don't value my time. I absolutely don't value my time. So it's free. That's all free. We only got the cost of parts here, which is really nice. I've already bought 3 sensors. And interestingly, like the first 2 sensors sucked. It was just like bad. And I hate going through data sheets. It's so like just annoying. And it turns out that the first 2 sensors I bought, you have to calibrate it. So basically you get some readings out of the sensor. You get basically RGB values. They're just like some number. And then you have to convert those into what they call the CIE spectrum, which is some more nerd shit. And then you take that and you can convert that into the color temperature, what we're looking for, the thing that we're actually trying to get to. But the coefficients that you need to apply to each of these RGB values changes depending on the sensor that you're using. And what sucks is like you have to calibrate it in order to find those coefficients. That's the whole point here is I'm trying to build a calibration. Like I don't want to calibrate shit. I'm building a calibration thing. I don't want to do more. Don't make me do more. So the third one I found, it's like self-calibrating. I'm like, okay. That's what we need. So I finally found a sensor like that. I got that going. I'm going to build a color temperature meter so that I can calibrate my camera. And then finally I'll be able to take photos.
It's a lot of work to take a photo.
I know, right? You can't just point that thing and click the butter. Yeah,
it's amateur hour.
Yeah, come on. We got to put more work into this. It's
way more work.
Yes. Like I was saying to you earlier, unfortunately, this project, as opposed to my other projects, might be useful, which is a bad thing. I need to come up with a more useless project. The thing that sucks about this is I'm going to calibrate the camera once, and that's all you need.
That's so much worse. Oh my God.
Just once. But it's still cool. It's like, whoa. I think all of us have wondered, what temperature is this light? We're all wondering that constantly.
All the time.
Yes. You just want to know. You're like, boy, this seems like a cool light. I bet this is like, I don't know, 3,200 Kelvin. I'm not even sure if that's the right one.
I don't remember if the value goes up or down for the temperature.
I have no idea. I'm so bad at this. I have no idea. I don't know. But
that's why you're building a tool.
Exactly. Yes. I'm building a tool for this. I don't need to know this. You build a tool for this. It's like,
right,
I don't remember anything. I don't think or remember anything at all. That's why I always read the source code. It's like, well, I can just go read the code. Why do I need to remember shit?
A little bit of just-in-time knowledge, right?
Yes, absolutely. I mean, remembering stuff is for losers, man.
I mean, humans invented writing for a reason.
Exactly.
So we didn't have to remember.
We don't have to remember stuff. Yes, that's why I got a calendar. I love the calendar. If it's not in the calendar, it doesn't exist. Not going to work.
sometimes if it's in the calendar, it still doesn't exist, to my brain at least.
Yes, indeed. Yes, that's a project I'm working on at the moment. I'm having a really, really great time. I don't know. It's a lot of fun because it's like, oh, I took a photography hobby. How do I get programming involved in this? I don't mean to get programming involved in it. It's just that
this happens.
Like, well, when all you got's a hammer, you know what I'm saying?
Sure. Yep. Yeah, every single thing. That happens in programming too, where you're like, I found this cool thing you can do in Rails, and suddenly every place can get solved by this unknown, obscure Rails concept.
That's why all of my websites are just WebSockets all the time, just only WebSockets. That's all it is. Don't even need to update. Yeah, don't need live updates. I don't even care, but still WebSocket. Just
what is HTTP anyway? We got
idea.
WebSockets.
No idea.
Amazing. Okay, so out of respect for your time, we'll wrap this shit up. But this was awesome. I was very nervous going into this podcast recording, which I never get nervous for podcast recordings anymore. I used to get very nervous. I still get a little nervous because I'm like, I want this to be good and I want the other person to have a good time. But like, I was talking to Aaron Patterson, who I guilted hard into coming on my show. I have to make it good. So this is great. I have to say out loud, thank you for everything that you're doing for Ruby, for Rails, have done for us, and for the countless hilarious keynotes that just have been the best part of every Rails Conf I've ever gone to. Has been.
Thank you. I really, really appreciate that. It's very kind of you.
And thank you for coming on the show, setting time out of your day to just talk about all the cool things. Anytime you're working on something and you just want to talk about it, feel free to come back on. Love to have you.
Sure.
The format doesn't change. It's what are you working on? What blockers do you have? What's something cool you got going on? And you always seem to have something cool going on. So
we never have the what's cool going on at our stand-ups. I got to integrate that.
Sounds like you need to integrate that. Yeah, bring that back to Shopify and get them working on that. And then let me know if you do, and I'll include that in the show notes too.
Nice.
So, Aaron, for those who don't know, where can people find you on the internet?
You can find me on Blue Sky at tenderlove.dev, or you can email me. It's aaron.patterson@gmail.com. Oh, and then I got to plug my YouTube channel. What am I thinking?
Oh, yeah, of course.
I'm so bad at this. It's Tenderlove's Cool Stuff on YouTube. Yes, come watch me live stream once in a while. I keep a strict schedule.
Of occasionally,
yes.
But always great content and great guests on that one too. So I will include all of that in the show notes.
All the show notes.
Yes. You don't even need to listen to this episode. Just read the show notes and click all the links. But hopefully you did listen to this episode and you enjoyed it. And we will see you, or I will see you at least, or I'll be in the next one. Aaron won't be. I will be. But I don't know how to end a podcast. Can you tell? Okay, listeners, I'll see you in the next one. Bye.
Bye.